Thank you. English, yes. So my name is I'm Stein Tronstad. I work with SAP as a solution advisor. And first of all, I'm sort of afraid of heights, so I'm going to be standing over here a bit, if that's okay with the camera. Okay, so I got the invitation from Ronny to come and speak, and I didn't exactly know what to talk about, but I sent him this blurb. And I'm sort of reading back to it, especially after, thinking about that bear session you just had. This is a bit too, I don't know, too ambitious, too boring, too serious, to be honest. So we're going to skip this, and we're going to talk about puppies and muffins instead. So I hope that helps a bit. All right, I'm a solution advisor within SAP, and we are doing tons of stuff these days when it comes to technology. And technology which are not most often associated with SAP. So we're doing things in Kubernetes, we're doing things in Docker, we're doing things in Python, machine learning, and all that stuff. So I'm going to talk to you today about our solution when it comes to bringing machine learning algorithms into production and into different kinds of systems. How many of you sort of know the basics of machine learning? Oh, quite a few. I'm no expert, I'm no data scientist, so you can put me in my place pretty directly if you want to. But I just wanted to show you a few examples of what SAP are doing sort of in the machine learning space. And if you have a look at this one first, this is something called SAP Brand Impact. And what it does is reading video stream in real time and picking out the different brands and doing analysis on these brands. So you can see we got Tag Heuer up here, we got Kenwood, Eurosport, and at the end you can see how often your brand has been represented in that video. And also, you can drill down to and whereabouts in the image or in the video stream your brand was mostly displayed, for instance. So this is done in real time, and it gives you a nice set of metrics to see how your sponsorship or how your commercial branding has been recognized when these kind of videos are going. Another example is through our sales pitch, sales thing, this thing called S4 HANA, where we actually have technology. This is through a Skype call with a customer. So we read his facial expressions, and we try to figure out, we do a speech to text analysis as well, and do sentiment analysis on top of that. So is he a happy customer, or is he sort of not happy with us? We also do text analytics. It is a bit difficult to read, I know this, but we also do text analytics on his Twitter feed, his social feed, to see if he's sort of friendly towards us or not. And the reason why I show you these things is that when it comes to machine learning, and machine learning actually implemented in real solutions which have been deployed into the market, SAP are at the top. We have so much machine learning and artificial intelligence going on in our products. So we are out there, bar none. And most of these products, most of these solutions are built atop on a technology platform called SAP HANA. And I guess most of you have heard about this, hopefully. Yeah. All right, so the Hana Platform is our platform for everything when it comes to our solutions, our ERP solutions, our data warehousing solution, and so on and so forth. But you can actually use, as Ronny just mentioned, you can have your own HANA box, and you can take these machine learning bits and use them yourselves. So the things that we're going to concentrate on today is our predictive analysis library, our automated predictive library, and our Tensorflow integration. So just real quickly, I'm going to go through the different bits. All right. So the automated predictive library. All right. People like me, who's not a data scientist, who's not a statistician, I can sort of understand this. I mean, if I want to do if I want to know who will sort of leave me as a customer, who will commit fraud, I can do a classification. I can sort of understand that is a classification algorithm. I can understand that we need regression to do sort of to find a value. How much is the fair price of a used vehicle for instance. Time series forecasting, it sort of explains itself. So we can do this without knowing too much about the actual data science underneath. I'm going to show you a bit of this later on. The next one is if you are a data scientist. We also give you direct access to all the different, so you see you got classification again, regression, cluster analysis, time series, but we also have different algorithms underneath. So for a data scientist, he can actually, who knows the difference between a cart analysis and a random forest, he can pick and choose his own algorithm. Yeah, and we've done analysis on how much worse the automated is against the fully fledged data scientist algorithms, and the APL, the automatic, is not too bad actually. It gets you there pretty easily. So just to show you an example, this is the PAL in which a data scientist. So first you have to sort of select your algorithm. In this case, cart. You have to do the records of parent. You have to do the records of leaf. You have to think about all these different parameters. So to predict a price based on these features, what type of gearbox is it, vehicle type, year model, and so on and so forth, you could use this cart algorithm. On the other hand, you can go and use the PAL. And it's a different example, but it's the same kind of thing. You just want to know this. How many people are going to be leaving us or has been leaving us as a customer based on their age, job, if they're married or not. So we just select the target column. We got the features in place, and we just throw the thing into the HANA box, and it will do the analysis for you. Same result, but you don't have to fiddle about with parameters in this case. All right? So these are this is of course statistics. This is statistical features. If we want to do things with speech, images, and text, the market leading, if I could put it that way, at least we think so, is this Tensorflow, what's it called? Framework from, is it Google? Yes, it is Google. Is it? Yeah. So we can integrate with Tensorflow, and you can either do, you can actually, in your HANA environment, since this is based on Cloud Foundry, you can put a whole TensorFlow cluster underneath your HANA box, just for your knowledge. So if you want to mess about with TensorFlow, you can do it on-prem, or you can do it in the cloud, or you can use our machine learning foundational libraries, which is basically a set of 27 APIs. Let me see if I can actually show you this. All right, so we got tons of stuff in there. We got machine translation, optical character recognition, similarity scoring, and so on and so forth. These are services that's in the cloud, the SAP Cloud Platform, which you can sort of connect to from your HANA box, and they will use that in place. Okay, the last thing is, of course, we also want to recognize that there are tons of machine learning frameworks and algorithms out there as well. So we support these four at least, and this is a very small selection of the stuff you can actually put into our data intelligence platform and use. As you can probably sort of see, if you know these things, this is mainly based on Python. So the scikit-learn is a Python framework. Jupyter is, well, I guess Jupyter can be used for other things like R, but it's mainly used for Python. Then we got Python and R. But there is other stuff in there as well, which you can bring into the SAP HANA platform environment to develop your solutions. So let's take an example. A very simple example. So you're walking along the street and you see a nice Mercedes-Benz. You take a picture of it as it drives past you, and you try to figure out what kind of car it is. This is using our machine learning foundation. Oh, you can't see this? Oh, sorry. Is that better? All right, so you take your picture, you upload this to this API, and it has a look at the picture and tries to figure out where is the car in this picture. So it does a frame recognition, and then it looks at, are there any wheels in the picture that we can sort of recognize. So it finds the wheels, and then it tries to decide on which rims are used on this specific car. And then it scores this for you, and it's thinking, this is most likely an E-Class, basically. And it's the color is polar white, and the wheels looks like they are S-76R. And then you can sort of, if you're interested in the car, you can go directly to the Mercedes-Benz dealer. And you can start configuring that car that you just saw driving past you. All right, it's a simple example, but there are bits and pieces happening underneath which you want to have a look at. All right, so the first thing is, then sort of just realize in the middle here we have something called a pipeline. So instead of messing about with Python scripts, which you can do if you want to, you can build this out of predefined operators for you and sort of in a drag and drop environment. So it does three things, this stuff. So when it comes to the color recognition, it takes your input image, then it masks it to try to get rid of all the noise in there. Then it does a simple color histogram. Can you read the boxes? No. Okay. It does a color histogram, and it thinks that it is that red on the top, which got a 0.28% chance of being that color, and then it delivers that result to the application. This is statistical analysis. What it also does is try to figure out the class of the car. And to do that, it needs to be trained on the different cars. So what Mercedes-Benz has done in the background, they have taken tons of pictures of their Mercedes-Benzes from every angle, and they put them through a process which looks like this. So we take the picture, and it looks at the picture as a picture. It doesn't know anything more about the picture than it is a set of pixels, which will have a different set of colors. And it pushes it through something called a neural network. I won't go into detail because I don't know too much about it myself. But that picture ends up as a vector, which is a mathematical representation of that picture. Then it's told that it is an SUV. This is a truck. And based on tons of these pictures, it can sort of classify this into a truck, van, SUV based on probability. It's thinking that this is, in this case, a truck. Of course, if you put a cat in there, you will still get a probability that this is a truck. Yeah, but it's not. It's going to be much more confused. Did that make sense to you? All right. Okay. All right, but that is just one small bit of what it does to have a fully fledged machine learning environment in your own data centers. So we talked about the model training bit, also model validation. But first, the most important thing about it is basically to recognize that we do have a machine learning scenario in place. We want to do some machine learning because we need that functionality into our applications. So just the thinking about getting to a machine learning stage is also something that takes a bit of work. Of course, then you have the machine. You want to do something with machine learning. Then you have to figure out where is your data. Basically, do we have proper data? We have to have data discovery. We have to data processing, because machine learning is very important that the data is valid and clean and correct. So there's tons of other stuff going around to create that simple machine learning scenario I just showed you. Yeah. So what we've done is that we have tried to take all the different bits and pieces and formalize them into a product called SAP Data Intelligence. All right, so that was that was where the blurb came from on the beginning. Yeah. Okay, so data intelligence, remember that. I was going to do a demo, but of course that just crashed literally 2 hours back. So I have to do with screenshots. I hope you can sort of forgive me that. I'll try to walk you through it so you understand what I'm on about. But yeah, unfortunately, it's going to be screenshots. All right, so the first, as I said, you can mess about with scripts, but now you're able to do your training through a predefined operator instead. This is a predefined TensorFlow training model. And the result looks, no. As it would look if you were training a TensorFlow model. It goes through the training, it repeats its stuff, and then it ends up at the bottom with a score, accuracy, 0.9129. So we are pretty happy with this model. We could then go back and tune the different parameters, which I talked about in the beginning, but this seems like a very, so more than 9 out of 10 images will be recognized correctly in this case. Okay. Yeah. So let's start about talking about actually finding the data discovery, data processing, and try to work out how we do this most in the best possible way. We do have connection types, which means we can connect to, as of now, 31 different systems. We got everything from Google Cloud storage, S3, buckets, so on and so forth. We have MySQL databases, Microsoft SQL databases, Oracle, we get OData, and everything like that. The one I want to point you out is this ML cluster, which is, you can actually point it to a machine learning foundation account in the cloud as well. So you can push your data learning and data scoring algorithms into the cloud. And we also have, which is not on this screenshot unfortunately, our own data lake. It's basically an HDFS cluster running underneath the system. So you have somewhere to store your models and your training data without going outside the systems. So in this case, I have connected to 15 different bits and pieces. Okay, so let's say you got a new system up running. There's a new HDFS system in your environment. And the steps I'm going to be describing now is not probably the way that you're going to do it as a proper data scientist. But let's just, for argument's sake, say that it's a new HDFS system coming up into your environment. And you've been tasked to have a look at the data and see if there's anything we can actually do with it. So you drill yourself down. And this is not an HDFS system, this is a HANA database, but the same sort of thing applies. So we got your schemas on the left side. So we drill down into a schema called TA01, and we find this table here called used car prices. And we're thinking, let's have a look at that used car prices data and see what it looks like. All right, so we've got a set of cars, which is a limousine, Mercedes C-Class, from the year 2000, it's a manual gearbox, got 160 horsepower, but at the end here we got a price. So if you remember the first slide, based on this feature at the end, is there some way we can actually predict the price? So this is a perfect sort of learning data set for a machine learning algorithm. So let's have a further look at the data. All right, we drill down into the data and we see that, there's a few interesting things here. We got a price of 0. That's probably an outlier. I don't think anyone sells 0 value cars. All of them are petrol, so there's no diesels in place. None of them has been damaged. So on and so forth. We need to clean up. There's no value in this damage column, for instance, because that's just the same. It's a no value all over the place. We got null values and blank values in some of the columns as well. We need to remove that. What else do we have? Yeah, there's also just only manual drive, so there's no automatics in here. So we might sort of drop the gearbox, sorry, where are you? Yeah, the gearbox column, it doesn't give you any value. So things like that. This is what data scientists do. They have a look at the data and try to trim it and figure it out how to do the best. So we have a look at this table and we go one step further. We load this into something called a data preparation step. So for instance, we want to take away the damage column. We can then remove this here. We can filter on, not null, so we take away all the null value columns instead. This is something you, of course, can do in Python. But as sort of bringing machine learning to the masses, this is, a bit easier for novices and things like that. And then when we have trimmed and done what we need to do, we still have a null value here. We need to take care of that. But we can actually save that to another data set and use that as the new machine learning algorithm. And that gives you the opportunity to do things like this. So I won't go through all the text, but let's just say that, all right, you want to, as a business, you want to figure out the different price, what would be the different price with the same exact car, but the one that's got 50 kilometers on it and one that's got 150 kilometers on it. So you run this algorithm and it pushes down and it gives you the result that the machine learning algorithm thinks that the one with 50,000 on it would be 154K and the one with 150 would go down to 126,000 euros or dollars or whatever it is. Which is a valuable thing to know, I would think. Mm-hmm. All right. So the next thing we want to do is something called model creation, model training, and model validation. And just to give you a bit of background on the example, there's a very famous data set called the MNIST. I can't remember what it's for, but it's basically a set of 60,000 handwritten digits. So this has been used to train in SAP everything from, there are still countries in this world where you do checks, for instance, where you write, and the KID numbers on your autogiro and stuff like that. So the handwriting recognition, on this case, has been used in many different scenarios. And what it does, it takes those images and it creates this vector again. So in this case, it splits the image into 28 vectors. You can see, 1 is where it's black and white. So it does that both horizontally, columns and rows, and then it creates a vector of it. Okay, we also want to create a vector of the what it actually is. So in this case, we had a 0. We want to create a vector of a 0. In this example, we use 2, so we create another vector, 10 digit long, and we're putting a 1 in where, so this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So the question basically gets from, we have a vector of the image, we have a label, given this vector here, what would be this vector? So this has been reduced to a mathematical, statistical analysis. And then training this model, it gives you some interesting heat maps. So for instance, if for a 0, it should be empty in the middle and has data around it. For an 8, you can see it's a bit more confused, but you can sort of understand that it shouldn't be any, I'm not totally sure I totally agree with this one, but you get the picture. So it should be black there and it should not be black on the other set. Okay. It's going to be a bit of jumping around. I apologize for that. So we can load this into this one. I can sort of. We load this into our tool again, and we create something called a machine learning scenario, which in this case is called handwriting recognition or something like that. And we put our training data, the MNIST data set, into our data intelligence store, the HDFS layer I just talked about. We have some Python notebooks, some pipelines. In this case, it's going to be representing the actual program accessing and using this model. We have 2 pipelines. One is the one that actually trains the model, and the other one is an application that you can call from an API. I'm going to show you this later. In this case, we have 2 models, and this is important because we need to retrain the model every once in a while because of data skew. So in the case of a car example, if there's a new model in the market, we need to retrain the data because we need pictures of that new model. If a model has been removed, and so on and so forth. So the repetition of creating the model, relearning a model, is also important to have control of. Okay, so if we go into the training module, we can see that it fires up and it does some stuff, and it gives you some metrics. And these metrics looks like this. It's the same metrics as you showed last time. It's a accuracy score. How good is it? Is it at? So out of 100 tests, it gives you the right answer 91 times. And the loss, this is sort of a fitting algorithm. How well does the algorithm actually fit the data training set? Did that make sense to you? Yeah. On the other hand, we have the serving algorithm, which has been deployed into our infrastructure. So this is now running, and it gives you this API on top, which you can access through your programs. So you can send images of digits to that API, and it will try to sort of sort out it will try to do machine learning on it. And the result looks something like this. All right, so we send this image here into the box. And as you can see, we know that this is a 4, or it's supposed to be a 4 because of the label on top. And the machine learning algorithm have looked at it. And if you remember the scoring vector, so 0, 1, 2, 3, 4 is pretty big. It's pretty sure that it's going to be a 4. It's got 16% chance of being the number 4. It also has a look at the number 9, which I can sort of understand. It kind of looks like a 9, but it's not. It's a 0.12 chance instead. Yeah? All right, another 9. It gives you a 9. It's very sure that it is a 9. All right, this one, label 4. Okay, it thinks it's a 7, actually. So there's a 0.14 chance of there's been a 7. And the 4 is 0.112. It's a very weird 4, though, so I can sort of, again, understand this problem. It's not perfect, but it's, again, this is a model that I just trained myself, so that got probably something to do with it as well. And so on and so forth. This is a 1 that is actually recognizing as an 8 for some reason. It's pretty sure that it's a 1 as well, but it's so 0.122 versus 1.127. Yep. And so on and so forth. I won't go through all this. 1, it thinks it's a 5. Yeah, so it's not perfect in any way, shape, or form. Oops. No. Come on. There we are. All right, so this is the pipelining. And again, I wish I could show you this real time. We got 200, I think it's 86 operators which you can use. And it's not only machine learning, but it's everything from integration to Kafka. There's machine learning. There's open APIs from SAP. It can basically connect to almost anything that's out there. And it can do transformations and joins and unions and what have you on that data and put it somewhere else. So it's a complete framework for developing applications as well. This is the training pipeline, and this is the development pipeline. So these 3 bits is creating that API at the end. Okay, so I think that basically that was what I was trying to present, or wanted to present. We have this thing called SAP Data Intelligence. It is taking care of everything from figuring out the machine learning scenario, controlling your data, doing the data discovery, processing and pre-processing your data, and also taking care of all your machine learning models. We have been selling this since June, and we got 100 customers on it already. I won't bore you with the customer list. And this is the architecture. Quickly run through this. All this is running on Kubernetes, so it's virtually limitless when it comes to scalability. If you want to put application into this product, you can do that, and it will scale, of course, at a cost, license cost, but it will also scale to limitless possibilities. I think that's what I had. That was 10 minutes for questions, if there are any.
Anyone? Jakob? AI, machine learning. Questions? Okay.
Yeah. I'll be around for 3/4 of an hour.
I know that some of this sort of training of the system is sort of need to be, let's say, client dependent. But did you mention about how you are able to sort of consume, let's say, the content or services that are, let's say, more trained? I mean, this recognition of characters.
Mm-hmm.
Do you support sort of services that are getting that more, let's say, like Google has for optical recognition?
Yeah. Underneath the, we support, to put it bluntly, there are also programming kind of operators as well. JavaScript, Go, PHP, Python, C, which you can use to connect to almost anything. There are OData operators, there are REST-based operators, so-called. I'm not sure I'm answering your question, but yes, you can connect to almost anything that is out there. So if you want to use Google or Azure's image recognition services, you can do that.
Yeah,
or other kinds of
that makes sense. But also, I think there's a lot of sort of processes within SAP or for SAP clients that are, let's say, more unique for SAP clients.
Yes.
And then,
okay.
I mean, the goodness of this kind of machine learning comes when you are sort of pooling up the content and bringing all your user into one model where you can sort of you don't have to sort of to train your own dogs. You can sort of consume that combined knowledge from all SAP users and clients into one common knowledge group.
Yeah, you can. It is actually meant to do like to get to that 360 degrees view. It got connections. It got very good connections to SAP systems. For instance, ABAP systems and everything can connect directly to this. Am I answering your question? I
mean, let's say if one customer, let's say one Equinor is working on their sort of artificial intelligence machine learning projects, and then you have, let's say, 15 or 20 other integrated oil and gas companies worldwide. I mean, how do you sort of make sure that they can sort of get sort of the value from the combined effort of training your systems, and that you sort of are not sort of doing this as a solo kind of thing?
Well, it boils down. You need to. It doesn't take away anything that you need to do integration stuff. So if you want to do machine learning across different sets of solutions, you have to pull them all together at some point, at least for training the models. Once the model is been deployed into your infrastructure, they can be reachable from almost anything. But to get the basis of the data or the basis for your models, you have to do some kind of integration. And that's why we support 31 connections out of the box, basically, so you can connect to and have a discovery towards most storage analytical bits and pieces out there. There are also connections to things like ETL tools, so you can sort of trigger a sample extraction and put it into the data intelligence framework to work on that for you. So you pull data from different systems into a system, and then you do the machine learning bit, and then you press delete the test data, but you have the model in place. Yeah. So the integration is still there. And that's still a huge, problem when you want to do it on a big level. But again, the infrastructure for this is it's getting infinitely scalable, like the Gmails and the things are there. So you can most likely you can work on very large data sets, and also you got the power of the HANA database underneath. So usually you pull data towards your client and then do your analysis on that. Now we could do your analysis on the full data set instead. So it should generate more complete models in the case.
Because as I'm working so mostly on the application part of SAP, and of course the interesting part here is that when you're trying to build in the cleverness and the machine learning, artificial intelligence capabilities within your applications.
Yep.
So you don't have to that they're smarter and more efficient and better. And then of course then it's important to have the combined efforts from all clients. Then of course
there are hooks in our applications which can take these serving methods and put it into your ERP, for instance. So you can add machine learning, I don't know, windows with extracted machine learning information on top of your S4 box, for instance.
Yeah.
So the models you produce, or more important, the APIs that gives you access to the models can be easily, you can easily extend your S4 application with machine learning from this tool as well. Yeah.
Anyone else? Okay. Thank you.
Oh, no worries. Thank you.